then in YouTube something should be happening. Let's wait a little bit. Okay, I think we are live on YouTube now. And of course, insecure statements like that are always the best way to start live recordings on YouTube. So, as Olga already said, thank you everybody, welcome. This is the brief explanation, just a rerun basically of the stuff that we already explained in the pre-registration. But we thought it could be useful to just start with this rundown, so that if people have any questions, they can think of them again while we go through this stuff. So, the idea is, actually the Open Digital Health was born a long time ago when Gil and Dom and Robert and me were basically deciding that it would be useful if we had like a big database where we could actually find all these great tools that we develop. Because it's quite a common scenario that people have a project, they develop behavior change tools, and then at some point the funding stops, and then the project kind of dies and the tool is not found again. So it would be nice if actually we could collaborate more and reuse more of these components. So that's what we want. We want to have an interface where people, professionals, maybe even end users, intermediates, researchers can find information on open digital health tools. Then of course the question is, if you want to start with something like that, how are you going to get to the information that needs to be in the database? Because of course to have this front end that people can search, you need to have some huge database on a server somewhere that has all the information. So we thought we would start with a systematic review to just systematically canvass the literature and map out what we know already. Then we extract all this information. Then we have first a systematic review or a database with systematic review information that we can then ask research questions to and write articles about to tell the world about the state of open digital health. But we also have populated this database, and then we can build another interface that's more user-friendly for practitioners, professionals, etc. So that was the idea. So we set it up as a systematic review, and I don't know whether everybody has done some systematic reviews, so I just thought I'd start at the beginning. With a systematic review, usually you start with a search strategy. Usually the main component of the search strategy is some query with like key terms that you combine with and or, etc. And then you enter this into a bibliographic database. And then you get loads of hits, thousands usually. And of course, only a small number of those are relevant. So then the next phase is the screening, where you apply exclusion criteria to ditch everything that you don't want. Then in the next step after that, the included articles, you go through those and you extract select bits of information. The bits of information that you'll need to answer your research questions. And then afterwards you can analyze all this. For some reason this phase is called synthesis in systematic reviews. So you synthesize everything and then you have some overarching answer. If you plan systematic reviews, it's the other way around. You start at the end. I know that that's kind of common for planning in general, but it's also the case for systematic reviews. So you start by thinking about what your questions are and which analyses you need to do to answer those questions. Then you think about what you actually need to obtain from the sources, the articles for example, to be able to answer those questions. Then you think about on what grounds you want to exclude articles during your screening phase, and then in the end you know what your search strategy should look like to make sure you find as many of those articles as possible. So in this planning, this procedure that we're in now, we focus on the extraction. Because we don't actually have any specific research questions here. Our goal, after all, is not to do like a scientific study. We just want to fill a database that we can then tag an interface onto so that professionals and practitioners can look for information about open digital health tools. We don't want to know which ones work best or whatever, although of course we can still ask such questions to the database once we have it. But in this case we have more of an applied goal and we're not driven by hypotheses or research questions as much. So we start thinking about the extraction. And that's one of the hardest bits of systematic reviews, because this is the point where you kind of decide which doors you close to yourself in later stages. After all, if you don't extract certain entities, certain bits of information, you won't be able to look whether they're important once you do your analysis. So for example, in our case, we could think about whether we want to extract characteristics of the target population of a given digital health app, or the programming languages that were used, like PHP, Java, Python. which determinants, psychological constructs, were targeted. So does the tool try to enhance people's self-esteem or their self-efficacy, or change social norms, or change the way they attribute things? And each of these can be more or less specific. So if you look at target population characteristics, do you want people's age? Do you want their sex? Do you want gender as well? Because of course psychologically gender could be argued to have more of an effect than sex. For programming languages, you also want to get the versions. Does it matter whether an application was programmed in PHP 6.1 or PHP 7.2? Do you also want to know the libraries that were used? Because often these programming languages come with libraries that are created by different sets of people that have a number of functions that are used in creating a health app. And of course, if people want to use this health app and contribute to it, for example, they will need to have the same libraries available. And of course, as it works in the world, libraries don't stay available forever because people move on to different projects, etc. So do you want to extract at that level? Then if you look at the targeted determinants, do you extract them in the author's own words? So if they say this app increases people's exercise knowledge, then do we just say, okay, exercise knowledge is now a psychological construct and we extract it like that? Or do we actually recode this? And if we recode it, how do we deal with this? Where do we get these definitions to recode into? Because generally in the literature, definitions are super brief. So if you want to code constructs, you need to first develop a set of definitions or decide that this is another huge project, so we code in author's own words again. This same problem exists for other entities we have to think about. So if you think about gender, for example, again, do you use author's own words or do you code into categories? Do you want to get everything down to 3 categories, like male, female, NB, like non-binary? Or do you also acknowledge that there are more categories? And then you can end up with loads of categories. And if you have loads of categories, how useful will that be to our end users, who will eventually need to have an interface where they can filter these health apps? And then if for gender, they have 50 different categories to select from, and most categories will only have one health app, is it still useful to our end users? So those are the kinds of considerations, kinds of decisions we'll need to take now. So basically the core 2 decisions are which entities do we want to extract and where do we extract them on the so-called coding categorization continuum. With on one extreme coding, basically we just extract things in the author's own words. And then we commit to, at a later stage, coding it like qualitative data to categorize it afterwards. Or we just categorize in advance, which is the easiest choice if there is a clear existing kind of taxonomy, ontology, set of categories. But if that doesn't exist yet, that means you have to develop it before you can do the categorization. So these are basically hard choices that you have to do with any systematic review, of course. So in this round 1, what we are mapping out among everybody who collaborates is which entities does everybody think we should extract. So those are the things like programming language or the year of publication or the authors or the effect size or whatever. So what are they? Why should we include them? Are there any existing coding instructions or ontologies or categories that we can use? And because usually when people think of a given entity to extract, they'll probably have some affinity with it. So they might also want to be involved in eventually developing the coding instructions that we will be using in round 3 of this project. And then we might end up with a list of like 100 entities, and we might not want to extract 100 entities. So we also ask people which criteria should we use to select which entities we actually will extract. So that we can get from a long list of 100 entities that 1 or 2 people each think is interesting to a short list of like 20 or 30, so that this first round of the systematic review is actually doable, manageable. And for these criteria, we need to have a name, a definition, lower extreme, upper extreme. So for example, some criterion could be whether it's easy to extract. So for example, the year of publication is super easy to extract. Another criterion is whether it is useful to the end user. Year of publication is probably not super useful to the end user. But it might be useful because if it's very old, of course, the software that was used to develop the app will probably not be supported anymore. Then in round 2, we move on to the actual multi-criteria decision analysis to apply these dimensions to each of the entities. So we ask everybody how they want to weigh each of the criteria, and then how people rate the entities on the criteria. And then, because we aim to have quite a broad representation in terms of disciplines, we also ask people how confident they are about the rating. Because of course one of the rating things could be whether it is important for virtualization, which is, so whether extracting something is some entity, whether it's important to have that information to know whether an application can run in a virtualized environment. Most people who are not IT, involved in IT, don't know what virtualization is. That's completely fine, but they will still have to rate this dimension, so they can indicate I'm not confident on rating this because I have no idea what virtualization is. And on the other hand, you could have some about behavior change, like how useful is this, is extracting this to know how the intervention actually works. That's something that psychologists, for example, will be quite familiar with, but coders, programmers, will probably be less familiar with this. So that's why we also indicate how confident you are about rating entities. And then in the end, just to establish how many we want to extract, we would like to get a ballpark estimate of everybody of what they think is reasonable. And of course, the more entities we extract, the more populated our database will be when we start out, when we launch it. So the more useful it will be to people. But the more work the extraction becomes. And then with all this, we create a table kind of similar to this, where you have the entities in the rows, and we have all these dimensions, these criteria that we come up with ourselves in the columns. And then everybody rates these entities on each criterion, and we aggregate all this, and then you get some estimate like this. So for example, the 4 example entities I have here, they're all not very informative as to the behavior change model, the logic model, as to how an intervention should actually achieve change. But they have varying scores. I mean, this is just something I came up with, this is not real, of course, but varying scores on how easy they are to extract or how stable they are over time, stuff like that. Fortunately, I'm not home alone, so somebody else can get the doorbell. Unless, of course, it's my partner who locked herself out. Oh no, because we have a solution. Okay. Yeah, so that's basically the idea of round 2. And then after round 2, we know what we actually want to extract. And then we'll start developing the coding instructions. And developing the coding instructions we'll do in little subgroups, because that will probably have at least dozens of entities. So it's not doable to do that with everybody at the same time. Plus the coders will have more affinity with the tech stuff, the behavior change people with the behavior change stuff, etc. So ideally people kind of pick some entities to flesh out close to their expertise. And then in the end we'll have excellent coding instructions. We'll all comment on them so that they are useful and everybody can understand them, so that the instructions that the coders came up with are understandable for practitioners, and the stuff the practitioners came up with are understandable for policymakers, etc. Well, and then basically we can move towards the last bits. So then we can think about the exclusion criteria and the search strategy. Those are considerably easier once we know what we actually want to extract. And then we pre-register, and then we can start. I'm pretty sure this is the last slide. So are there any questions that anybody would like recorded for posteriority? Keep your peace for now, and then I will deactivate the recording. Let's see how that works.